developing a complicated system for users to create other systems, and I will let him explain all of that. But I have to, this is a unique case where I have to modify the statement I made earlier when I said I could introduce every project by saying, and now for something completely different. It's actually exciting because I could say, and now for something completely different, which has some overlapping ideas with the previous presentation. And I think that's really exciting because a lot of the ideas that you guys share, you went like this, and it was fabulous to see your presentation, and it was fabulous to see yours develop for a year. So, Brent.
Hello, thank you for being here. My name is Brent. I'm going to be presenting my thesis, which I'm calling A Related Matter, Active Ownership Through Connected Design. By way of introduction, I'd like to share the following examples from the internet category, There I Fixed It. These are images of people solving their own problems in their everyday life using whatever is handy. Sometimes ugly or unsafe, the permanently temporary solutions depicted in these photos represent a kind of user-improvised innovation that is all around us every day, but which is rarely seen for what it is. Rawly functional, clever design. Two words I like to use to describe these user modifications are workaround and bricolage. Workarounds are established by users to make their belongings work for them. In effect, workarounds are a user's coup d'etat, an inventive wresting of authorship from designers and manufacturers with their short-sighted view of the functional challenges facing users. Bricolage is a silly-sounding word I use to refer to the process of improvising from whatever materials and means are nearby. The term comes from an art-centric discourse, so it's no surprise then that artists and designers have extensively exploited the aesthetic and methodology of bricolage in their work. Notable examples would be the ready-mades of Jasper Morrison or the work of artists like Tom Sachs. For designers, workarounds are generally significant as product gaps. In other words, when designers see these things, they tend to think of how they could improve the existing products to address the workaround, or how the workaround is illustrating an untapped market that they can then fill. To me, though, workarounds are evidence of creative strength and their author's resourcefulness. They didn't just find something to buy. They looked around at what they had. They thought about what they needed, and the solution they came up with visually implies that whole creative story. For example, here's an easel that my wife threw together once. It's as simple and temporary as possible. You put paintings in between the chair and the tape down pencil. There's some wax paper protecting the seat from straying paint, because after the easel is finished, it becomes a chair. In starting my thesis work, my main question was, how can I facilitate this sort of creativity? How can we, as designers, help more people have that creative problem-solving experience? How can we make the practice of design more improvisational and more accessible to non-designers? Instead of trying to annihilate the workarounds of the world, we designers should be working to encourage them. With this goal stated, I immediately was struck in something of a conundrum. As I see it, the primary function of the designer is specification. Designers specify materials, processes, forms, and uses. But it seems in bricolage, the user takes the business of specification upon himself. In a sense, there's a sort of conflict between the user and the designer as to who makes the decisions, who wears the pants in the relationship. As a designer wanting the user to wear the pants, I initially felt a little vulnerable. What exactly should be my role here? The more I specify the use of a design, the more limited the creative capabilities of the user become. I needed to figure out the line between my authorship and the creative user's authorship. On reflection, I realized that this conflict might not be so intractable, since the concept of use can be thought of as part function and part application. The function of an object is abstract and constant, while the application is concrete and varies case by case. For example, holding, grouping, joining, might describe the abstract function of a binder clip. The intended application of the binder clip is to group and hold large amount of papers together. Perhaps a secondary application would be hanging the bound material by the handle. In the previous example of cord management, the bricoleur subverted the design of the paperclip. The primary application, one could argue, is performed by the handles, which spins the cord, keeping them from falling behind the desk. The binder here, clipping onto the desk, is slightly secondary. In other words, the user has reassigned the hierarchy of applications within the binder clip. In doing so, the user shares in the object's authorship. This is what I refer to in the subtitle of this presentation as active ownership. When we define the use of the objects we have acquired, they become ours, personally, emotionally, even spiritually. Thinking of use in terms of function and application provided me with a moment of clarity regarding designing to the bricoleur. As an abstract function concept, holding and joining was to become the primary focus of my work, as this seemed to me to be the primary problem of the bricoleur. Attaching anything to anything else as a design problem focuses the designer's concern on the connection, and that's where I wanted to start. As in the easel shown earlier, the ability to return materials to a native or reusable state after use is a crucial concept for bricolage. One of the main messages of most work in bricolage related to material is related to material value, as if saying, look what else this object can do. Bricolage focuses on the potential of materials. As a result, I wanted to focus on connections that could hold materials without altering them. Designing clamps seemed to be the natural place to start. The way I thought of this project was that I would design a clamp that attached itself to one object, say a tabletop, and have it connect to another clamp attached to another object, say a flashlight. I had a table and a flashlight, now I have a task lamp. After drawings and daydreams about how such a clamp would look and work, my first mock-up was, functionally speaking, a horrible failure. Holding these three boards upright was about the extent of its function. A far cry from furniture-grade joinery. But I learned a lot and made some decisions that would become fundamental to my methodology going forward. In picking materials to build with, I chose a threaded rod size, 5/16 of an inch coarse, and decided from that point on to make it my standard whenever possible. Standardization was among the first tenets of the methodology I was developing for the bricoleur, mainly because once you begin to work within a standard, all your connections become simplified. And creating a whole from parts becomes a lot more intuitive. My second go at the clamp was an idea involving multiple thread points. After drafting up several takes on the idea and pricing out how to test them in metal, I had sort of reached the end of my partnership with Masonite. I realized the most sensible way was to buy some small, cheap C-clamps and modify them. So I drilled holes and tapped threads into the C-clamps so they could be connected like this. And this simple solution led me to another motto: don't start from scratch. In the initial design phase of the clamps, I had gone far out and tried to imagine a clamp that would grasp anything. But here I began to realize that fixing an object to a point in space was going to require a system of relatable objects if I was to achieve this goal categorically. So I set about to formulate a construction set, basically a human scale erector set capable of supporting a fluid lifestyle of improvisational problem solving. First, I wanted to lay out some basic building materials. Obviously, the 5/16 gang was going to come along. One drawback being that it kind of lacked in compressional strength and would just bow under pressure. So, having already admired broomsticks for their ubiquity, inexpensiveness, and standardized usage from brooms to paint rollers to light bulb grabbers, I decided they should be a material element for my building set. Finally, I decided I probably couldn't do much better for a surfacing material than wood in general. Pretty much the greatest stuff on earth to the bricoleur. It's strong, light, easily workable, readily available, and in keeping with with the aesthetic of bricolage, I obtained a large amount of reclaimed boards. So these were the basic parts of the building system. I then set out to design connections between them. Broom handle to broom handle, threaded rod to threaded rod, threaded rod to broom handle, and so on. Fundamental to the building system would be establishing XYZ joints, a three-dimensionally perpendicular connection. I'd already experimented a good deal with how this might come together in various relationships, but now with the basic materials established, I was able to get more specific. One XYZ connection I designed is this object I call a ring node, which provides ports for 8 directions of threaded rod to attach perpendicularly to a broom handle. I also wanted to be able to make connections over more dynamic angles. So I began designing ball and socket clamps that included rubber knobs with threaded inserts. The design I settled on uses 2 of the same part to connect the ball to. Two ports of a ring node, 2 ring nodes side by side, like this. Or can be used without the ball to direct threaded rod parallel to a broomstick. Between threaded rods, I designed a series of connectors as well. Here are some other XYZ joints for 4 directions between threaded rod. The mostly cylindrical one on the right here actually fits inside of the ring node on the left for even more directions of connections. Another useful, let's see. Over the course of building with these components, I realized that sometimes there's a need for a rod with 2 fixed points to be brought into tension. So I designed these geared tighteners, which have hex nuts embedded in them. Turning the gears tightens or loosens both rods at once. So to make any whole design, you need to make lots of parts. Luckily, I convinced the guys at MakerBot Industries to donate to the department one of their new 3D printers. So I pretty much dominated that also. Final section of the construction set consists of adapted parts. These parts perform specialized functions. The first of these objects I brought into the set was a polypropylene light bulb cage. I've always found the function and shape of this object really appealing since I pulled it off a construction site last summer. So I began to think of ways to pleasantly diffuse the light while maintaining the functional aesthetic of it. And I had a lot of different ideas for this at first, and finally I decided the thing to do would be to sew a simple slip cover, and I chose linen to reference the classic homey lampshade. It's not really too tricky. Next I found these swoopy plastic chairs, just the seats actually, in the trash some while back. I really wanted to bring them back back to life in some context, so I refinished them with the rest of the building set. I built bases for them. One final adapted part was the bicycle kickstand. People are always throwing these away in New York. I guess that around here there's always something to lean your bike against, and the stand is just extra space and weight. So I experimented with using them as little table legs. So before I go on to the actual application of those, I've gone through many of the constituent parts with which I've tried to create and curate a functional building language. I should now talk about the summation of all this work, which is the ARM, or a related matters set. Presentation of all the individual parts and usable organization was a daunting task for me. For a while I'm obsessed with the shapes workflows take, I'm a pretty poor organizer. The initial design for this set looked like big shelves or workstations. But as I began to explore the building of them, I realized it would be better if each subset could be easily detached and function apart from the rest. So I ended up with 4 boxes, 3 smaller stackable boxes containing various parts, and 1 large chest on kickstands to contain the various tools used in building with the arm set. This set, as presented, is by no means complete, nor should it be. Just as I bolted this furniture together, it can be taken apart to make other things. Other parts, tools, and materials may be added or subtracted. After all, the idea is to take the things you own and to actively own them. Thank you.
Lights?
Have you ever come across this anthropologist, who was actually coined this term, bricoleur, and he was making this large comparison between bricoleur and engineer. I think it would be really interesting.
Yeah, definitely.
Yeah.
What was his name?
Claude Lévi-Strauss, it's the same as Strauss, but
So your next steps, where are you going to take it?
I actually just kind of brought it to the point where I have started making them. So I'd like to make a lot more. At this point, the raw materials I have just present so many possibilities. And I've kind of found in the last few weeks that actually trying to build things really helps with the design process. And I mean, in immeasurable ways, you kind of realize the things that you always want and the things that don't always come into contact.
But are your goals more to take this system and sell it to someone else, or like maybe you become
yeah.
more furniture?
So yeah, that's a good question. I'd like to just kind of make a final catalog of all the materials included in this set. Also, because many of the connectors that I 3D printed were pretty much specially designed for the MakerBot in which I printed them, I'm going to be sharing all of those on the MakerBot database. Pretty much try to put out as much as possible just for fun.
So, great concept. It's interesting that a lot of the objects that you actually ended up making are objects that once you sort of made it and adjusted it to your personal preferences, you're never really going to readjust it. Like once your chair is the orientation you like it, it's not like you're going to constantly fiddle with it. So maybe something to explore in the future, go back to the things like the desk lamp that's got to move, or the connector cables disappear, that as new technologies, cables get swapped out, something that's going to require that level of fitting.
Yeah, it's
You've allowed for so much fitting, but the stuff that you've actually done is like once it's set, it's set.
Yeah, I think that's a great comment. One thing that about those boxes, the smaller boxes that I found interesting is they're all, I don't have a really good picture of it on the inside, but the inside and the divisions of the boxes are all modular. So as you use materials, find new parts and do that sort of thing. One thing we do is we adjust the little compartments there. But that's a great comment.
I think your project reinforces the idea that the greatest moment of human creativity is an unexpected adaptation, rather than conceiving of something in a relative vacuum. Not only you get something that pulls in previous intelligence that went in it, but you open up this idea of being witty by recontextualizing something. And there's a great pleasure in this kind of area, which is also why it kind of migrated into art and utility and all that. And you kind of don't know where it's going to go. but very lively things came out of it. There's lots of character, and I think that's not easy to get. Nice job.
Thank you.